Okay, I'd like to welcome everyone to Denby Dale Amateur Radio Club. Great to see you at tonight's meeting. Most people here are regular visitors. We've got one or two new people in tonight. You're always welcome to attend any of our meetings, as we say all the time. You don't need to be a member of Denby Dale Radio Club, but if you decide you want to join, you're more than welcome as well. So good to see you, and particularly pleased tonight to have speaking tonight from Boston. So it's not tonight for them, it's only the afternoon. Bob W1IS and Bob KC1DSQ. And what drew my attention to Bob's work, the two Bob's work, was an article that they published in QST earlier this year about a wire beam antenna. And I think we've been talking for quite a long time, haven't we, just informally between ourselves about what kind of antennas we could possibly, that are simple to put up and have got some benefits to them, that we can put up at Farnley Tyres. As soon as I saw their QST article, it occurred to me this would make a great antenna for our portable work as a club over at the field at Farnley Tyres. So I'm not going to steal their thunder, because I know apart from talking about the basis of your QST article, you also want to talk about some other work you've done as well on a 20-meter antenna. So Bob, I'm going to hand it over to you.
Can you let me share my screen?
Yeah, I've done it already.
Okay, I got to find it now. Where is it? Here it is. Okay. Let's do the desktop if it will do it. And then I'll get the image out and we'll go here. Okay, can everybody see that?
We can, brilliant, thank you.
Okay, great. This project started before Bob and I got together, when I started working on it a long time ago, before actually EasyNet and all the NEC, the simulated software came out. And I built one for our club for field day, and it was okay. But then with simulation, we were able to do a lot better. And Bob and I decided to refine this design about a year or two ago. And this is the result. And we've been using it in our club for field day, which is the club that's nearby. We actually meet in the Concord Rod and Gun Club for our field day. We have a beautiful facility there. And so this is the result of Bob and my collaboration. The goals were to put it so that we can move on a van or in a van or on a roof. So that limits the span of it to 10 feet, which is kind of short for a beam, but nonetheless it does seem to work. So the configuration is not what you would expect. It's a driven element and a director versus a driven element and a reflector. Our goal was to have good forward gain. And by the way, the reason why that configuration is it's shorter distance for the driven element to the director versus a reflector. We wanted good forward gain. The front to back was whatever we could get, because it's field day. We kind of like to just work people mostly. But since we're on the East Coast, we like to work people to the west for the U.S. field day. We use wires, not tubing, and simple with no massive matching network or confusion. That was one of the problems I had when I started it. I didn't have good numbers, and I used charts, and it wound up with a very weird matching network. So here's the layout. It's quite simple. We use 10-foot 1-inch dowels for the spreaders, and the driven element is adjusted carefully, and we'll talk about that in a minute. And then the director is adjusted to set the tuning. Notice that the rope harnesses are not symmetrical. We had a problem because QSD decided to make the diagram symmetrical. And then we got a whole bunch of emails that, how come I can't make this thing horizontal? Was this supposed to be shooting at the sky? Because the coax pulls it down. And well, if you make it asymmetrical, you can make it level. And of course, they left that out of the article. So Bob and I were inundated with you stupid guys don't know how to do this. And why is it vertical? Well, that's because it wasn't published correctly. Anyway, if you do make it asymmetrical and adjust it on the ground by one person holding the harness and just keep moving it until the thing holds level, it will hold level when you pull it up in the air, and that works pretty darn well. So that's the configuration. It's quite simple. I have a van, so we can move it in my van. And the interesting thing about this antenna, I'll go back here, is that all you need is a 1-to-1 balun on it, because it turns out if you tune it just right, the impedance of the antenna is 50 ohms, and that's very good, and that gets rid of all that crazy stuff. So this is what we use for the balun. It's just a 5 turns of 8x on a 5-inch diameter, and just roll it up and tape it together, and that's what we did. And it gives you about 10 dB isolation on 40 meters, which seems to be more than enough.
Yeah, symmetrical. So
yeah, it makes the antenna symmetrical, so it helps to have a balun with some isolation in it. And this is the simulation of the antenna on EasyNet, and then what we found when we built it. And my gosh, it came out pretty close. The gain it depends on the frequency, and if you look at any 40-meter beam, you'll notice that they often have 3 different settings for the element lengths, and that's because at 40 meters it's hard to get a good beam that will work well right across the whole band with the same SWR and the same front to back. They don't tell you that, but if you do the simulations, you'll figure out that that's exactly what the case is. So it's got some gain. The front to back is not great. It depends on what frequency you're at, but at 7.2 it's 5 dB, and at 7.05 it's 8.5 dB. It's not bad. The takeoff angle is 40 at 40 feet in the air is 40 degrees, and that's pretty good for working continental here. It turns out one of the tests that we did with it is there's a net that runs out of the south here on 40 meters called South Cars, and often the net control stations are anywhere from the Carolinas down into southern Florida. And I used to try to check into it with my dipole, and I'd get into it once in a while. When I put the beam up, I got into it every day, no matter where the net control station was. So it clearly has some useful gain. That, by the way, that antenna, this one is set up for sideband. The minimum SWR is just above the middle of the band, and that's what gives you the good response all the way up. So it's not very good at the lower end of the band.
But you get the higher band when the SWR is going off the edge of the.
Yeah, you get the higher gain as the SWR goes up, believe it or not. So, and that happens everywhere. So now, what do you do for CW? You tune it down to the bottom of the band, and you get results similar to the sideband one, and it works quite well that way. We built 2 of them. One is used for the sideband station for field A, and the other one's built for the CW station. And we've had several people who've built them since we had the article out, and all with good results. So I think they're getting similar results to what we've got. The trick to making the antenna is the tuning. And what you do for sideband is you put the driven element up without the director, and you tune it for minimum SWR at 6.8 megahertz. Then you add the director and continually make it smaller until the minimum SWR is 7.16, and then it gives you the curve that we just showed you. And for CW, you tune it 100 kilohertz, a little lower, 6.7 megahertz, and do the same thing and set it for minimum SWR at 7.02, so that you work most of the CW band as the SWR is going up, which gives you the better gain and better front to back. It stays within the range of most rigs, so it's at the high end of the tuning, it's still in the less than 3-to-1 range, but usually it's around 2, and rigs seem to like that okay.
Yeah, most of our antennas we try to do with an SWR under 3-to-1 or under, because there's a lot of machines with internal tuners that can go up to 3-to-1.
Yeah, and Bob has a 7300, which works only to 3-to-1, and we use that to test, make sure that we can actually match it with the 7300. So that's the 40-meter beam, and it's simple, it's movable, and it doesn't require fancy matching, and it works.
We had a team a group that sent us a note. They'd gotten together the day before field day and built it, and so then they used it in field day, and it worked better than their other antennas. So they were very pleased with it.
Yeah, that was that. We got a nice note from them. Yeah, it was the best antenna they had for field day, and our club used it. Unfortunately, I couldn't make it, and Bob couldn't make it to our field day this year. I had surgery, so I ran field day from my home running QRP on CW. But the folks there said the beams worked great. So if there are any questions on this one, we'll take them now, because the next thing we want to talk about is our other project, which is about to be published in QST, and it's a 20-meter phase dipole. And this is a wild antenna, and another one that could be easily movable, and it works gangbusters. So we'll take questions on the 40-meter one if you guys have any.
All right, brilliant, lovely. Thank you, Bob, and thank you both of you. Anyone got any questions to the two Bobs on the first antenna, the 40-meter beam? Darren.
Yeah, have you thought of adding a reflector to that?
Yeah, except it would require another 10 feet of spreader, and we thought about it and then discounted it because it doesn't give you that much more gain.
No.
It gives you another dB or so. So there really isn't a lot to gain with it. Somebody asked me that the other day. Why would I put up a 2-element beam when I can put up a 3-element beam? And I said, you can put the 3-element beam up if you like the extra dB or 2 you get from it. It's not that much gained. Get up to 5, it starts to show something, but at 3, it's marginal.
Yeah, Darren, I think 7 dB gain isn't bad, is it, for a 2-element beam on 40 meters?
It's 7 dBi. It's actually, if you measure it over a dipole, it's about 3.5 to 4 dB, depending on how high you put it, which is basically a half an S unit, which is pretty good. It's like doubling your power. Yeah,
it's very good. Have you run verticals on 40 as a beam?
No, I haven't done that, but verticals, we can talk a little bit about that in the next section here, but you know, we also had an article in CQ, I can't remember the issue now, I've got it, we'll get it later, on comparing a vertical with a dipole. And when you do all the numbers, it does indeed prove the fact that a vertical is equally bad in all directions. And in most directions, a dipole, even on 40 meters at 20 or 30 feet, will beat it. So the beams work, the two element beams made out of 2-element vertical beams. But we find that the lower angle of radiation is helpful, but it depends. It doesn't give you that much gain, though. In fact, it's loss.
I've always found a vertical array quite successful, but then I've always used it near the sea.
Well, that makes a huge difference.
Which is a different ball game, of course.
Yeah, verticals. In fact, a friend of mine, in fact, Bob and I know him, we worked with him, has been doing de-expeditions, and he's been experimenting with verticals, and they try to put them on the beach, and they work very well there, and because they have what I call the saltwater amplifier.
Yeah, we've got someone in here who's probably going to contribute a bit later, Bob, who's got a lot of practical experience of running verticals near the saltwater. I'm going to take Terry next, and then I've got a question from Mike at G4GUG. So Terry next.
Okay, thank you. Decades ago, I was led to believe that a two-element beam was better implemented as a reflector-driven element, and that was preferred over a driven element director. Given that the material difference between the two for your build and the way you've put it on the diagram, it's only a bit more wire on each element. So I wonder how you came to the conclusion that the driven element director was the better option.
Well, and we were forced into that decision. It turns out
You
that
ran out of wire, don't tell me.
No, it's not wire. It's spreader. We were constrained to a 10-foot separation.
Ah, right. Okay. Yeah. Gotcha.
And the difference between a reflector and a director is not all that much. It's a dB or so.
Yeah. Okay. No, it is the spacing between the two bits of. Thank you.
Yeah, if we've done a reflector, it would have been worse.
Yeah, and a supplementary question, if I may, you've decided that the takeoff angle is 40 degrees, or give or take. So is that low enough? Is there I mean, my idiot way of thinking is, well, point it down 40 degrees and then it would just hit the horizon, wouldn't it? But I know it doesn't work like that. So
No,
40 does seem a bit high to me.
Well, don't forget, we're only at 40 feet off the ground. That's where it was meant.
Yeah.
And that's for portable use. You put it up a little higher, the angle will drop.
Yes, indeed.
So if you can get it up 66 feet, you can get it around between 15 and 20 degrees.
Okay.
Which is what you'd like for DX. But again, this was built to be portable, give you some gain, allow you to work. As I said, in the US, across the country, it works quite well at 40 feet.
Right. Okay, thanks indeed. Very good so far. Keep going.
Thank you.
I think you've just answered, Bob, a question that Mike G4GUG had put in the chat, and that was what height did you put the antenna at? Did you settle on? And you've just answered that 40 feet.
Yeah, we do all our tests at 40 feet for portable things because getting it much higher is pretty difficult.
Yeah. Yeah, that's true. Yeah, I mean, you've the mast you need for it, or scaling a tree is quite a lot more difficult, isn't it? I agree. Next one was Mike also had a supplementary question. What about a Moxon configuration? Did you try that?
Yeah, we talked. Bob and I talked. We want to talk about Moxon.
So yeah, Moxons are very good, but you still need more than 10 feet for the separation.
Right.
And they're kind of touchy. I guess the spacing of the gap is pretty critical.
The other problem is it's physical. How do you make a simple antenna that you can put up and have the parameters come out every time you put it up? And so it's a level of complication that we wanted to avoid.
They have an amazing front to back, though.
They do.
Yep.
Yeah, the front to back on a Moxon is very good, isn't it? But,
yes.
Yeah, I mean, I think that's what we've all been struggling with, Bob, is in doing portable work, you don't want to spend half the day there getting your antenna up, do you? You want your antenna to go up nice and simply and without complication. So you're spending most of the time playing with radio rather than playing with putting antennas up. And I think it's trying to reach that sweet point between the two, isn't it?
Oh, yeah, I've been in charge of antennas, HF antennas for our field day for like 10 years. And the first time we did it, some folks brought some 3-element beams and masts and towers, and by the time we got it up, field day was over. And so we started to simplify and make it a little more rapid deployment. And right now we deploy two 40-meter beams, two 20-meter beams, two 80-meter end feds, two receiving antennas, a G5 RV, and a 20-meter and 6-meter loop in about 4 hours.
We also did the NFED.
Oh, yeah, right. And some NFEDs. So it's a lot faster if you think about it, and making the antennas easy to deploy is important.
Putting all those antennas up, I've got a question to you in terms of separation of the antennas, because that's quite important to avoid breakthrough on radios, isn't it, on things like field days. So how much space have you got to put all these antennas up?
Yeah, okay. We have, one of the things that we learned is that if you use a K3S or a K3 with the new synthesizers in them, you can put them 2 antennas end to end at about 300 feet and never hear each other. And so we use radios with nice clean radios, and that makes the difference. We only have 4 stations up, so we can spread them out a bit.
Okay, I've got another question from Ian, M6ITH. Do you have a picture of the antenna actually in use in the field?
You know, it's so hard to get it because once you put it in the air, the background is so much you can't see the antenna. There's not much to it. If you look at the first slide, that's it. It's just 2 poles and a bunch of wire, and boy, putting that up 40 feet in the air, you don't see, it's hard to get a good, we tried to get pictures for it. They wanted one for QST, but we couldn't get one. It just couldn't take a picture that showed the antenna because we put it up amongst trees, and the trees show up more than the antenna does. Just can't see it.
Okay, anyone else with any questions to Bob? Yeah,
Please.
Jeff, OSA NC.
Is it turnable? Is this antenna turnable? Because you talked about the van and so on.
Yeah, it's only
Rotatable, yeah.
It's not rotatable, but you can flip it 180 degrees. And the way you do that is just pull the coax and it'll flip right over.
Okay, great, thank you.
Yeah, rotating it's pretty hard because we hang it from trees.
Okay, yeah.
Try to move the trees.
We haven't got any movable trees yet.
Yeah. Yeah.
The beam width of this is fairly broad too. It's about 88 degrees, 85 degrees in that range. So you don't have to be that accurate in aiming it.
Okay, yeah, thank you.
I've got Brian next. Brian?
Yeah, yes, thank you. Because it's directional, for us, what use is it going to be? Are we going to point it at Europe with the back to America, or at America with the back to Europe? And what happens north and south? You know, we're right in the center of the country here. We're not at one edge.
Well, yeah, that's a challenge. But with the broad beam width, if you set it up directing it so where the major populations are, you can always flip it 180 degrees, which gets you pretty much all of it. The other thing you do is use 2 of them. They're inexpensive. You can put 2 of them up. Can't quite hear you. Say again.
Yeah, I think the main direction would be Europe at the moment, but that wouldn't be where, if we were seeking points, possibly where we'd get the most points from.
Well, you could always put 2 up at 90 degrees and basically cover the world.
Yes,
they're inexpensive. 2 pieces of wood and some wire.
You still got to hold them up at 40 feet at either end.
That's the problem.
I've got a question from Ken, EA5. He's out in Spain, G4VZV. My question is, did you not consider a delta loop easier to put up and only 1 dB less?
No, we didn't.
Straightforward question there, Ken. I did see, Bob, that various people have done some work on a vertical loop antenna, haven't they, for HF, with some good results.
Oh yes, a friend of mine uses one. He does very well with it.
Yeah.
I have a loop for 10 meters that works quite well too.
Okay, anyone else with a question to Bob? If not, shall I shout if I've missed you? If not, Bob, do you want to move on to your next bit?
Yeah, this is our other project to make a pair of dipoles phased on 20 meters using the same kind of configuration. And these are basically the 3D patterns of that antenna. And this antenna has some very interesting characteristics and actually blew us away when we first put it up in the air. We want to use the same spacers as we use for the 40 meter wire beam. Get more gain with the horizontal antennas than you do with the vertical, and we did all the calculations on that, and that's basically why we did it. It's also easy once you have just two pieces of wood, it's easier to hang them up. But both elements are driven in this case, because this is basically a simple phased array. So we control the phase between them, and by doing that, we direct the beam of the antenna wherever we want it. And the way we do that is by adding a phasing line of coax between the two beams, and we can steer the beam, and then we can reverse it electrically by just changing the way we connect it. So we use a relay in the control box to flip the phase, so we don't have to go out and pull the coax in this case. Just flip it over. And where we are right here, if we aim the antenna northeast, southwest, we cover pretty well into Europe and also cover pretty well to the US. So it's a lot of fun for us right here. So the design, usually we're missing some of it here. Let me see if I can change something. There. Go ahead, Bob. You want to take care of this part?
So if you go look for phased dipoles on the web, you'll find mostly vertical stuff, and people use what's called Christman phasing. It's a certain phase shift in the line, and some people have claimed to adapt it to horizontal antennas using the same phasing, and I don't know. I couldn't get that to work.
We tried.
So we came up with our own scheme. So the first problem is that we don't have 90 degrees separation with 10 feet. It's 90 degrees is like 17.3 feet, and we've only got 10. So what we did is we made up that difference by increasing the phasing line. And so what you want to do is, I think this is the next slide actually.
Okay. Oops, what happened?
Oh,
not working. Maybe that'll work. Yeah. Whoops.
okay,
It went too far.
okay.
It's a little slow. All right.
Okay, next. Oh, okay.
This
Okay.
rep sale and this one.
Okay.
I don't have the other one in here.
So anyway, what you want to do is, okay, I guess you took that slide out.
It's,
What you want to do is you get 90 degrees between the antennas, and then you introduce a 90-degree phase shift into one antenna, and in one direction they subtract, and in the other direction they add. So you get cancellation on one side and addition on the other. So we do, since we can't have that because we don't have 90 degrees. So what we do is we just make cancellation work out. We let the addition not happen as much. But that basically shapes the directivity of the antenna, and the directivity is what gives you most of the gain.
yeah, the interesting thing is, if you think about an isotropic radiator, which is a sphere, if you will, and then you start squeezing it. You can squeeze it so that it goes out one way, or you can squeeze it so you don't have anything going out the back way. And that's basically what we do, is we improve the front to back ratio, and by doing that, we actually get gain as well. So instead of looking at it from how do I get the gain, which is what we did for the 40 meter, we look at how do we get the best front to back, because it's the only way you can think about it when you only have 10 feet of separation or 52 degrees versus 90. And this was several months of consternation between Bob and me while we worked on this to figure out how to actually optimize it. And this does work.
Okay, so we've got two dipoles separated by 10 feet, and this combo box is suspended by a rope down the middle. So we have feed lines going out to the two dipoles. And the first thing we did is we made the dipoles 50 ohms by using 75 ohm cable. And 66.6 feet 4 inches of the 75 ohm cable gave us 50 ohm antennas.
I go to the combo box.
Okay, yeah.
Yeah.
Right, okay.
I'm gonna move this out of the way so we can see it. We're having a little problem here. Yeah. There. Okay.
Okay, so the box that you saw there in the middle contains a one-to-one balun. There's a relay which selects which dipole gets the phase delay, and when you combine these two antennas, you get about 9 ohms. So you need a serious matching network to do that. And then there's the relay itself, which switches. I think I said that. Okay.
Oops. Back up. There it
Okay,
is.
so this is what's inside the combo box. So this coil you see here is 14 feet of RG316, and the feed line
It's right there.
right. So the feed lines are 6 feet 4 inches, which is nice because they needed to make it 5 feet over to the antennas, and then you have this relay that either feeds one side directly and the other side through the phasing line, or you can swap which one is fed directly. And so this shows the combo box. We call it the combo box. And so this shows the one-to-one is this toroid here.
Yeah, let's see if we can do this.
Okay.
And then the relay.
The relay and
Yeah.
the matching
The
network is over there.
Yeah. Matching network is here. And then this is the bias T to feed the relay.
Okay, so it turns out you have to be real careful when you build this because it's real easy to have parasitics screw the whole thing up. We used a pi network for the matching network because that was easier to build reliably. The parasitics were less, the values were larger, so the parasitics were a smaller fraction of the total reactances. So it's, and there's the combo box with the phasing line built in. And here's what the matching network looks like. We basically took a piece of PC board and we just cut it across here and across there. And we were able to put these capacitors, and the coil goes across these two, and the two capacitors go from there to there and from there to there. And so that can be done easily with just one-sided PC board. Okay, so the relay, as we've said, selects which dipole gets fed directly. It's a 12-volt single coil latching relay. And so a positive pulse will latch it in one direction and a negative pulse will latch it in the other. And initially we sent the control signal up there with a separate wire, and that was pretty cumbersome and it worked, but it just wasn't a good solution. So we built a bias T network to send the control signal up the coax. This is the bias T network. We use two 9-volt batteries. charges up a capacitor, and then we can select the capacitor, the polarity with this. And then a push button fires the capacitor charge through a low pass network to the antenna. On the antenna side, this receives it. It's just a low pass network. It just goes straight to the relay. So that was all simple and straightforward. And this is what we got. It's pretty darn good. 11.5 dB dBi, 21 dB front to back, and we have a 25-degree takeoff angle and a 75-degree beam width.
At 40 feet.
40 feet, yes. And nice low SWR across the whole band. So we put this thing, the first one we put up was first prototype, didn't have the ability to switch direction. It was just hardwired phasing line. And we put it up, we hooked it up to the KX3, and we got 5.5 reports. We pointed it towards Europe, and we got 5.5 signal reports from Northern Ireland, Slovenia, and Germany, as I recall.
And one other country. With 5 countries, we worked in about 20 minutes.
Yeah.
With 5 watts sideband. That kind of blew us away.
Yeah.
And then we flipped the antenna later on. We put it up with the bias T, and we were able to flip it. So we worked some stations in Europe, and we wouldn't hear anything else. And as soon as we flipped the antenna, we were hearing the stations from the southwest of the U.S., and we couldn't hear anything from Europe. That front to back ratio really is fabulous. We were just blown away by it. And we did a bunch of measurements with local hams and hams at a distance away, and it proved that the front to back ratio was basically what we were computing in the simulations. It's 3 to 5 S units, which is pretty amazing. And so this is a hot little antenna, and this is the other one we used at field day. And this is how we test. We sit in the backyard with the KX3 and test. Yeah, this is what we just talked about, and we had a lot of help from people measuring the SWR. So this is basically it. This is just a list of other articles that we've published over the last several years on antennas, and we also have a website which is up at the top, ocfmasters.com, and there's some articles on there that are not published. We're not there. Well, the original manuscript of the two element 40 meter beam is there because so much was left out of the QSD edits that we decided we put our own up, and then the rest are kind of articles of interest if anybody's interested in antennas. But anyhow, this is the one that's pending is the 20 meter dipole, and we have a deep dive into NFED half waves coming up in CQ on the December issue, and we've had a lot of interesting results with that. Maybe a little different way to make them too. And we've made NFEDs that will work at 150 watts up to 1200, which is not what you usually see. Anyway, that's it. I'm sure there's a bunch of questions that are just burning to be asked.
I've got one immediately from thanks very much. I've got one immediately from Mike G4GUG saying we're all old timers. How about a bobtail curtain? I've only read about them in old books. Ever tried one?
We did. You weren't around that time, Bob. Yeah, we put a couple of them up. We never got them to work very well. The biggest problem is getting the ground system going. But we've tried. Yeah, that's an interesting question. We didn't have good luck with them. I don't know why. Maybe we ought to do it again.
If I remember rightly, the original bobtail curtain was verticals, weren't they? So a number of verticals. So yeah.
There are 3 verticals. You feed the one from the center, and then the others are phased basically to give you the directivity and the gain. Yeah, there's a fellow that lives just down the road here who did a lot of work with that sort of thing, and he had a Sturba curtain in his huge lot with 5 100-foot towers, That worked very well.
Okay, brilliant. Yeah, thanks for that question, Mike. Right, anyone else with a question to Bob on the 20-meter antennas? Who wants to go first? Can't see who's waving at me. Roger, G4UFZ.
Yeah, hi Bob and Bob. Thank you. That was really interesting. The the 20-meter business. The distance between the driven elements is 10 feet, but
Yes.
your coaxes were 6 feet each. So did they sag between? Are they just sagging?
Yep.
Yeah,
They
That's
don't, they're not
fine.
straight. They're just sagging.
yeah, they just don't get in the way that way.
Yeah, got it. The elements are straight and the coax just sags.
Yes. Yep.
Oh, lovely. Right. Thank you. Yeah, that's interesting.
I've got Gerald.
Hi there, thank you. Yeah, it's very, very interesting. I wanted to try one of those phased aerial systems myself, and it certainly seems to work quite well. Is there any way of altering the phasing forward and backwards a little bit by putting some sort of tappings in it? And is it possible you could use twin feeder rather than using coax to like take the weight away over?
Are you, go ahead.
I'm not sure what your question is. Did you suggest that we use twin lead feeder or something, and rather than coaxes?
Yeah, I just thought it might make it lighter to use a twin feeder, perhaps 100 ohms, something of this nature. So
we're already
rather than using coax. So
we're already having to transform 50 ohms down to 9. So if we had to start higher, that would be harder.
Yeah, it turns out that the coax that we use for the phasing line is very light. It's Teflon coax. The 316 is really light. The combo box doesn't weigh very much, and we just use RG8X. You could use a lighter coax if you wanted to, or go to a Teflon, but there isn't really much difference. But then we'd have to build another matching network to get it up to hit the twin lead, and
so we ran that rope down the center to carry the weight of the combo box. So that kept it from pulling the two antennas closer together.
Yeah, the rope in the middle is the trick. That just holds all that stuff up, and it doesn't pull the antennas together.
yeah, thank you. That explains it. Very kind of it.
Okay, thank you, Gerald. Anyone else with a question to the two Bobs? What I was going to say to you guys, I know David Simmons posted up on our Facebook page yesterday a picture of 3 phased vertical antennas for 40 meters that the club used running a Lighthouse on the Air event a couple of years ago, and he believed that they got something like a 4.5 dB gain from the phased verticals. So not as good as your gain on this.
The horizontal antennas are definitely better than the vertical antennas for gain.
Yeah, we've done a lot of work on that. But this antenna, because they're both driven, is part of the issue, and you can actually squeeze the rear radiation towards the front. I don't think anybody's ever done a design like this, because all the designs we've seen is let's optimize forward gain, and we said let's optimize front to back, and that mentality got us an antenna that really does work. The simulation showed up in our models and in our modeling, and when we put it out in the field, it did exactly the same thing, which made us feel pretty good.
Yeah, someone's just asked Mike again. Have you tried it as a sloper, just using a single support?
No, I suspect it will work. The problem is it's going to change. Ground is a problem with antennas, and because the impedances at the ends are different. When you put a dipole one end closer to the ground, you've changed the impedance of the thing. So the whole matching is going to be screwed up. One of the things that we're working on right now is more end feds because you feed it from a high impedance. And we have one we're working on now that we just tested, an end fed for 20, 15, and 10. and we put it up as a dipole, would be horizontal, put it up as a sloper, and it behaves almost identically, because the impedance difference, because you've got a high impedance you're working with, a few ohms at 1,000 ohms doesn't, and you match it down 36 or 49 to 1 to 50 ohms, doesn't affect it very much, so you don't have to deal with that. But once you put this thing up as a sloper, you've got a different impedance to the ground, and that's from each side, and that's going to screw up the antenna. We have an article about that somewhere. Which one is it? I can't remember, but we wrote something about that a while back.
I mean, if that problem could be solved in some way, in terms of getting the angle of the slope right, you would have the ability to have that directivity not just between one side and the other, but around 360 degrees, wouldn't you, with a single pole?
Except not that easy.
No, I agree.
We looked at doing that. It's not that easy.
Mm.
Yeah, you would get some, but you'd have different angles. I mean, your takeoff angles would be different. This takeoff angle is quite low.
Yeah. Right, anyone else with a question to Bob? If I don't see you, just unmute yourself and shout.
What kind of power levels would the combo accept?
Power levels? Actually, this will take up I think we rated it at about 600 watts. It's quite a bit.
Yeah, you need beefier coax for the phase line to go higher than that.
Yeah. And the capacitors in the matching network won't handle any more than that. But it handles 100 watts, of course, very easily. But 500, 600 watts would be not an issue. I think we tested it with my KAT 500 amp, and worked we ran a long piece of coax out to the antenna, longer than usual, 60 feet, and we put 500 watts into it.
We wanted to make sure that the bias T didn't.
We wanted to make sure that the bias, we didn't want the bias T to be interfering with anything, and it didn't. So yeah, we ran it at 500. I think it would probably take up to 800, but that would be pushing those capacitors. So saying 500 or 600 watts is probably safe. We know 500 is. We tested it that way.
Okay, thank you.
Thank you, Jeff. Anyone else with a question to Bob on either antenna, the work they've been doing?
Yeah, Nick.
Yes, go on. Yeah, Roger.
Just another thought. You've done that, all the calculations and everything for 20 meters. Is that scalable then? I know you started with a 10-foot dowel, but is it scalable to other bands as pretty straightforwardly?
Pretty much, yeah. I think it's scalable. We haven't tried it yet, but I think it would scale very easily.
Yeah, 10-foot pole's ideal, but you could scale it smaller, perhaps. Is that what I'm thinking?
I think you could scale it larger too if you really wanted to, but yeah, it would scale to a smaller one. Would be not a very big deal. The biggest problem you're going to have is building the new matching network. They make sure that it works.
Yes. Yeah. Thank you. It's interesting. Thank you.
You're going to have smaller capacitors and smaller inductors, and then the parasitics start.
Yeah, you're going to start having things getting in the way of each other. But yeah, and getting all that to work in the box was a big part of the problem.
Yeah, you definitely didn't have that problem on the 2-element beam, did you? So I can see you've had to do some work to design that matching box there in this antenna.
Yeah, that took about a month.
I think this is the most aggressive antenna we've built.
Yeah, although I mean, a bit like your other antenna, once you've done it and you've done that work, it's just as pretty well as straightforward to put up again, isn't it?
Right. And again, let me put this back up just for the heck of it, if I can find it. There it is. These are some of the articles that we have, and most of them are on our website, which is ocfmasters.com. So if you want more, they're there, and you can just more than welcome to download them and read them or whatever you like.
Yeah, brilliant. Yeah, we do a club email, Bob, and I'll when I make reference to this meeting, I'll put your website up there. So I'm sure lots of us will be going off to have a look at some of the things that you've got there.
Yeah, we started out doing off-center fed dipoles, so we have a lot of stuff about that.
Yeah, and we actually, and for the off-center feds, you need some rather weird capacitors. So what we do is we actually put kits together. And then we've had requests for, we did the article on balance, which is being translated into Japanese by ICOM. And then people wanted to know if they could get a kit. So we put a few kits together. We're not really interested in making any money. We're interested in spreading the wealth and having people have as much fun as we are.
So have you ended up making a hybrid balance with both current and voltage balance together?
Right.
Is that the work you've done? Yeah.
Yeah. Well, there's a whole bunch of tricks to that we learned the hard way. But when you make a hybrid balun, you got to make sure that you isolate the two baluns because they do couple. The leakage inductance will couple, and when they do, when you're building an off-center fed, it really screws up the loading, and especially on the lowest frequency. And Rick, DJ0IP, had the same experience, and when we wrote the article, he said, "Yeah, we had a great conversation." So. Yeah, that's right. The other thing that we learned is that you need to have your one-to-one has to have plenty of isolation, or you will get RF in the shack. And a lot of the ones that are commercial don't have enough. And for example, we do an NFED that will be in the December CQ, and we use we actually put a counterpoise on it, not like the way they're doing it in the commercial stuff. Because we use the counterpoise of the coax itself. We've done it both ways with wire and with the feed line, but we will put the counterpoise from the balun, which is actually it's a transformer, from the transformer down to a 1-to-1, and we put a 1-to-1 that has minimum of 30 dB isolation, and then feed that into the shack. And I've been using a couple of them here. And I have no RF at all anywhere except outside, and it radiates like crazy, and it doesn't come into the shack. So you got to have a lot of isolation on a 1-to-1 balun. And anybody who says you can get a lot of isolation by putting a lot of cores over coax, I think you better think again.
Yeah, that's definitely another meeting, but I agree with you. That is particularly the design of lots of NFEDs does end up with a lot of RF back in the shack, doesn't it? If you're not careful.
Well, that's because they use the feed line as a counterpoise, and then they just let the RF go everywhere. And that's what got us started. I had a friend who got his license, wanted to get on the air, so we put an NFED. He bought one. We just put it up for him, and I couldn't get the RF out of the shack. And I said, "This is not right." And that's when I started looking into it. And then Bob and I got going at it, and we found a new way to make the transformers, which is different, and we actually use the coax, a piece of coax as the counterpoise, and it works beautifully.
Yeah, we put the transformer up at the feed point, and then we have coax down about 13.5 feet.
Yeah, for 80 meters, it's 13.
And we put the 1-to-1, so that 13.5 feet of coax is the counterpoise.
Right.
And then put your balun after that 13.5 feet.
Right.
Yeah.
Correct. Yeah. And it's 7 feet for a 40 meter. We have 40 meter, and this latest one we built is 20 meters, and it's only 4 feet of coax down to the 1-to-1, and that works well too. We had a lot of we put it on the air. We didn't work any DX with it. We worked some locals.
Yeah, I mean the advantage for most of us in the UK, of course, is the attractiveness of the NFED is the length of space you need to put one up,
right,
for HF, and that makes it very attractive for those of us with small gardens.
Well, please read the article, because we don't have it on our webpage because it hasn't been published yet, and we're kind of sneaking this one in because this hasn't been published either. But we thought that you, since you were interested in portable antennas, we give you both of the portable beams we've done.
Yeah, brilliant.
So anyhow, We're giving you
Yeah,
a preview.
Yeah, thank you. I mean, I've subscribed to CQ, so I'll make that available when your article comes out next month. I mean, it comes out on the 1st of December, doesn't it? CQ, they produce their December edition in December, not November, like everyone else does.
Yeah, they've tried to speed it up. We've been talking to Rich Moseson, the editor, and they're trying to speed it up.
Okay, has anyone else got a question before we thank the two Bobs for their presentation tonight? Last chance for anyone who wants to dive in.
Yeah, Nick.
Yes, go on, Phil. Yeah.
Yeah, I'm just reading through. Very interesting talk, by the way, you guys. Thank you very much. I'm just busy messing around with phased verticals at the moment. I noticed most of your work's been done on sort of dipoles and beams. Have you done much work in the past on phased verticals?
I did many years ago. Results were okay, but since we've been able to simulate, we haven't done much with verticals, phased verticals. We probably should. Maybe that's something, one of our next projects, but it takes us several months to get through these projects. So by the way, this kind of became our pandemic escape, is doing antenna designs. And so, but to get through any one of them and to get it into a publishable form and to get it repeatable so somebody else can make it, takes several months. It's a lot of engineering that goes into that, believe it or not.
Yes. I mean, I've spent hours and hours on these. I've got 40-meter phased verticals with elevated radials, and then two 18-meter spider poles for obviously 80 meters, and they're using ground radials. And I've spent hours, and God knows how much wire I've put down to, but they're working. I'm seeing an improvement in getting them to work. Quite comparable with the 80-meter dipole at about 50 feet now. So
that's very good.
It's coming on. It's coming on. Yes, it's been a lot of work, but I just wondered if you'd written any articles on phased verticals in the past.
No, not yet. We've only been doing this for 3 years.
Okay. Okay. Thank you. Thank you.
I'd like to hear what you've done though with your phased verticals. That might be worthwhile for you to write it up for us.
Yeah. Well, I'll drop you a line. Certainly. Yes, no problem.
That'd be great. Thank you very much.
Thank you.
And Bob, if you're interested in verticals, our member here, Ken, G4VZV, who is currently out in the south of Spain, has been having fantastic success with vertical antennas down by the salt marshes in southern Spain. Ken, do you just want to give them a flavour of how you've been performing out there?
Well, yes. Right. Well, I haven't phased verticals. I have done it at home, actually, back in the UK, but I haven't done it down here because basically because it's very warm, and to start setting phased verticals up is not an easy thing to do. But I'm not so sure, as there's only one thing that I sort of tended not to disagree with what you said earlier, and that was to do with the fact that having this 40-meter antenna up in the air, up at 40 feet or 60 feet, in the UK, it's very difficult to get an antenna up at 60 feet. In fact, there's a lot of gardens that are not even 20 feet long. So the problem you've got for the UK, rather than in the States where you've got a lot of real estate in a lot of cases, is that you can't put big antennas up that are, you're lucky to put a 20-meter tri-bander up in the UK or a hex beam. So when you're looking at an antenna that's many, many more meters long, it might have quite a narrow boom of 10 feet, but to have one that's so long of 60 feet each element is a little bit beyond most people. And that's why I think in the UK a lot of work's been done on vertical antennas. In my case, I looked on the benefits of having a reflector, I didn't go down the path of a director, because it appears to me that what you're doing is you're not bothered about the front to back, you're looking more for the gain.
Right.
And I think front to back is equally as important. And I think to put two phased verticals up, even on a beach, is not an easy thing to do. You've got to carry lots of poles, etc., etc. You've got to think about the wind near the sea, the breeze, whether it will pull the poles over. There's a lot more to it than that. So I went down the line of a single vertical antenna with ground tuning unit. And by doing that, I was getting the mirror image of a quarter wave directly below. And by sighting it at the side of salt lagoons, I was getting the perfect ground plane with a very low angle of approximately 17, 18 degrees. And I find that in itself is fantastic, because it's full on omnidirectional. And that's the sort of flipping what you've done on its end and looking at the alternative.
Yeah, I agree. And KZ1W has had an article in QEX about the one he built on one of the islands that they went to, a vertical array. And that's what he's been doing. He's been going on de-expeditions. Bob and I worked with him many, many years ago. And he's been going de-expeditions, and he's been doing similar thing, putting verticals on the beach, good ground systems, coupling it into the salt as best he can, and getting great results. So it does work really well. And the low angle for de-expeditions is clearly an advantage.
Yeah. The only other thing I did think of before I pass it over to someone else is, did you consider center-fed half-wave vertical antennas?
I've looked at those and they work fine.
Because you can, in fact, there is a company that's set up in the States, and I can't remember the name, but it's the same guy that used to run Force 12. And he has actually produced a 2-element rotatable tri-band beam using phased verticals.
Okay. Yep.
Yeah, and or the Sigma 5 is the old one, the Sigma series, and they work on the same principle. I just think, yeah, I think your idea is fantastic if you've got a lot of real estate, but in the UK, we don't seem to have that, and that's the problem.
Well,
But I take my hat off to what you're doing. I think it's brilliant.
Well, verticals are great. I had one for a while on 40 meters. In fact, it was published in QST years ago with just two. It was 10 feet off the ground with raised verticals, raised radials, and it worked quite well. And in some directions, it beat my dipole, but in other directions, the dipole wiped it out because it's just the way it is. That's just the way the numbers come out. But when you get a good ground and you need a low angle of attack, you can't beat a good vertical with a good ground system, and that's the trick.
Well, when I use the GTU, I get as near to 100% efficiency out of the quarter wave, and that's why it beats a lot of beat. In fact, on 40 meters, when the band is opening, I actually get over to the Pacific before any of the stations with the beams, and then it seems to turn on itself then, and then the ones with the beams are up there for a longer period, and the vertical drops off then.
Yeah.
But yeah, good. It's all good stuff. It's great.
It's all a lot of fun too, isn't it? That's what it's
Yeah. Okay.
Yeah, I think Bob, I think that's it, isn't it? This is about having some fun and trying things out and seeing what works and what doesn't work. That's what we all enjoy. And the great thing, of course, about your work, both of you guys in the States there, is when we're playing bits of wire and a few bits of dowel, the cost of building this stuff is pretty light. As soon as we start to make something out of aluminium and so on, it all starts to ratchet up in price, doesn't it?
It does. Yeah, it does. On the other hand, I just had to order 500 more feet of wire for our work. So,
could I just ask one more question, if that's possible?
Yes, go on, Kim.
I did once try a T2 Fox Delta antenna, which is basically a dipole folded back on itself, which is sloping. And I found that having 13 meters of wire on two large fishing pole canes was quite, well, it wasn't very easy structurally in the wind. And that's why I'm amazed how you've got yours quite level up at 40 feet. Because I tried sloping one, and as I'm pulling it taut, it's turning on itself because of its because of the length and the fact that part of it's lighter or heavier than the other.
yeah, well, that's where the asymmetrical harness comes in.
The other thing is we kind of assume that the coax comes straight down, and so that if it comes out to the side a whole lot, that produces more force. It tends to flip it. So it must
be a tremendous way that you've got. I'm still can't get my head around how you can keep it level, because the weight of the coax, and you also wound a choke.
Yeah.
So the weight of that must be pulling one side down considerably heavy.
Yeah, and that's, again, if you look at here's the diagram. If you look at the harness is asymmetrical, and you put the short side, which has to have more force on it, where the weight is. And when you do that, it keeps it level.
Right. Okay. Yeah.
And that's the trick. Otherwise, the thing will flip. It does exactly what you said.
Yeah. Okay.
Before we go on, you reminded me of a question there, Bob, and that was about wire. Have you ended up choosing your preference for wire you use for these antennas?
Yeah, yeah. We've come to the conclusion that using the flex weave from Davis Engineering is the stuff to use, because you can roll it up and it doesn't kink itself. It doesn't want to roll itself back up again. And it's very nice wire. We use number 14. I just ordered 500 feet. Let's see, it's Fox Whiskey 14 BK. That's black 14 gauge flex weave from Davis Engineering. I just ordered 500 feet at 21 cents a foot yesterday.
Oh, really?
Yeah.
Oh, I didn't know it was that cheap.
Yeah. Well, if you buy it from Davis directly, that's the way to buy it.
Ah, okay. Yeah, we also, when we were just doing a prototype, we might use the DHHN electrical wiring, which is dirt cheap.
That's even cheaper.
Yeah. And it seems to be about electrically equivalent. So
yeah, we've measured it physically, and we've gotten the data on it, and we've tried to find the difference in it from our own stuff, and it's exactly the same result as the Davis, but it's not as easy to manage. It really is hard to strip, and it wants to roll itself back up every time you lay it on the ground.
Yeah, I did wonder, because we don't have a lot of, I mean, although we can all buy, electrical wire to play with things, if you want to have something which lasts and is good to leave outside, we end up, we can get flex weave in this country, similar, I think, to your Davis flex weave 14 gauge. But what we can't get hold of over here is the wireman stuff, the multi-stranded copper wire with the steel down it. Is it CQ534 you guys used in the work on spider beams.
Yeah. Yeah, that's too bad.
Yeah, it's not available to buy in this country. No, we've got no retailers selling it. Okay, anyone else with a question to Bob and Bob before we say goodbye to them? If not, can I ask people to show their appreciation the normal way to our two visitors from Boston?
Yeah.
Yeah, thank you very much, guys. That was a really good discussion, and you know, as we were saying, you know, we've got a lot of you can see in the picture behind me on my my screen there, the field we've got available. We've got a lot of space, and we've got some very big trees, and at one push-up mast and one mast on a trailer. So we've got lots of scope for playing with some of your antennas, and I'm certainly keen on giving your
Run.
It froze. We lost you, Nick. Oh no. Can anybody hear us?
We can hear you. It definitely shows that this is live.
Okay.
Okay, well, Nick's gone. We can't hear him.
Yeah, not to worry. Well, yeah, as Nick was saying, we do have a lot of room when we go out to field day. So hopefully I will give a look over your designs and give it a go. I am curious to see it all strung up, and I appreciate you say the pictures are really difficult to see, but I'll try and take a picture should I achieve something that matches your plan.
Great, great. Well, this is fun, and that's a beautiful field you've got. It makes me want to go over and join you sometime.
Yeah, it's about. Sorry, I'm back again. My computer rebooted for some reason. It's about 800 or so feet above sea level, up in the hills here of the Pennines in Yorkshire. So good takeoff in all directions really from there, and very absolutely low noise because there's hardly any people.
Whoops, you're going again. I think Nick's computer doesn't like him.
No, it's my internet connection keeps going down for some reason. I'm on broadband, and our BT provider is mucking around tonight. Yeah, sorry, and I was just saying the biggest problem we've got is noise, and the noise level is from the noise that sheep make in the fields.
Well, I wish we had that kind of problem. It's not that way here. Well, thank you all very much.
Anyway, yeah, thank you both of you for brilliant talk, and good to see you.
Nice to see you all.